we had completed the nomenclature of ether. Is there any doubt in nomenclature of ether?
No, sir.
Okay. So let's just jump on the topic, that is preparation of ether. There are two methods to prepare ether in our syllabus. Preparation of ether. So first of all, the preparation of ether is from by dehydration of alcohol. By dehydration of alcohol. And we prepare, basically there was a chemical reaction of alcohol in which when we do dehydrate or dehydration of alcohols takes place, then alkenes are formed. So I'm going to compare this dehydration of alcohol, then getting alkene, dehydration of alcohol, then getting this ether. It's very simple. You just need to focus on the condition or the reagent or the condition like temperature, then you will get it. If you have a phenol that alcohol that is basically ethanol I am taking, and you are going to pass it through or react with H2SO4 at 343 Kelvin, 443 Kelvin, at 443 Kelvin, then what we get here is very easy. We will get CH2 double bond CH2. That means basically dehydration of alcohol takes place. And if you are going to again pass this or react this alcohol with H2SO4, but at temperature H2SO4, but at temperature 413 Kelvin. See, 30 degrees centigrade lesser than the above one, then we will get C2H5O, C2H5. It's very simple to understand. I will explain the mechanism, but first you are going to write it. It's very easy. And this reaction is basically bimolecular reaction, nucleophilic bimolecular reaction that we studied in the previous organic chemistry, nucleophilic bimolecular reaction. That means SN2 reaction. The mechanism SN2 reaction. That means basically back. So please do write it and let me know. Then I will move to the mechanism. I already explained the mechanism of this, how we are going to get ethene from ethanol. We had 3 steps in that, and now I'm going to explain the mechanism of ethanol to ether. And it also contains 3 steps. Please do let me know when you are done with this.
Yes, sir. Finish.
Come to the mechanism point, which is very easy to understand. Here we will have to, in the first step, we will do protonate. That means we are going to react this alcohol, ethanol, with proton. That means H plus. So I'm going to write topic mechanism and follow the steps. That is basically first one is step 1. And what I am going to do in the step 1, this is your ethanol, CH3, CH2, and then OH, and this one of the react with proton. That means we are trying to get protonated alcohol, and as you know that this oxygen has lone pair electron rich species, so it will attack it, and we will get a protonated alcohol in the way you can see CH3, CH2, and then we have O. And you know that this has H already, and this hydrogen will be connected with oxygen, and whenever oxygen makes 3 bonds, it will have a positive charge. Is that clear?
Yes, sir.
Now come to the next step, step 2, which is also very easy. This we got protonated alcohol. Now this protonated alcohol will again, or you can say this protonated alcohol will react with ethanol. So I'm going to take ethanol like CH3 CH2 and OH. That means I'm going to write OH like this, and it has two lone pair like this, and this ethanol is gonna react with this protonated alcohol. And as you know that oxygen, positive charge on oxygen is very unstable. Yes or no? I already told you. More electronegative element, positive charge on more electronegative element, very less stable. Negative charge on more electronegative element, very stable. Are you getting my point? Positive charge on
Yes, sir.
more electronegative element, very unstable. Negative charge on more electronegative element, very stable. So see, oxygen will try to basically what it will try to stabilize itself. So what it will do, withdraw electron from carbon, withdraw electron from carbon, and it will be eliminated in the form of H2. Now you can see at this place dehydration of alcohol takes place. Now, as you can see, since oxygen taken electron from carbon, carbon will have deficiency of electron. So this deficiency of electron will be satisfied by this oxygen. This oxygen will attack this carbon. So I'm going to write this part first, like this CH3 and then CH. Now you can see this oxygen directly attacked on the carbon. So oxygen is directly attacking on carbon, and oxygen donated its electron to this carbon, so it will have positive charge. And with this oxygen, hydrogen was there, so hydrogen is there, and oxygen connected to CH2, CH3. So I'm going to write CH2, CH3. Now see what is in the third step, which is very easy. Now again, this oxygen is very unstable because it has positive charge, because oxygen is very highly electron negative element, and when it has positive charge, it is very less stable, or it is very unstable. So in order to stabilize itself, what oxygen will do? It will take electron from hydrogen, and it will be stabilized, it will neutralize itself, and now it is stable. And now you can see our ether forms, and you can also say that basically in the first step we had added H plus proton. In the last step this proton is eliminated, and we get our product, that is ethoxy ethane, isn't it? So it's very simple. You can write it.
Yes, sir. Finish.
Very good. Now come to the next point, next preparation, that is Williamson synthesis, also known as name reaction. Williamson synthesis. It's very easy. Now see, in basically this is a very important method of preparation, or you can say uh, laboratory method of preparation for ether. And from this, we can prepare a symmetrical as well as symmetrical ether. It's very easy. When an alkyl halide, haloalkane, is going to react with sodium alkoxide, sodium alkoxide. it will have positive and it will have negative. So what will happen, as you know that this will have negative and this will have positive. So this will be ROR. You can see this negative or this positive will go to the R. Now oxygen negative and this is NX. So I'm going to give you question CH3, CH2, Cl plus CH3. Please name the compound. This is
Sir, ethoxymethane plus sodium chloride.
Is it ethoxymethane or methoxyethane?
Methoxyethane.
Methoxyethane, yes. So it will be, this is the byproduct. Main product is this, which has a name, methoxyethane. Are you done with this?
No, sir, still writing.
Take your time.
Yes, sir, finish.
Now see, as you see, saw that this is RX, it can be tertiary, primary, secondary, anything. So if I am going to give you a question like this, CH3C, CH3, and this is O negative, that means there is like this, and this is Na plus, and this is CH3, and you are going to react this with CH3Br. Please let me know the product, main product.
Sir, would be methoxytrimethane?
See what happens here. This is one, sorry, negative, this is positive. So this positive will go to this negative, and the product formed will be CH3 and then O. And I'm going to write this part first. So it will be CH3 and then CH3, and this will be CH3 and then O CH3. This is what you get. What?
Yes, sir.
So it will be like this 1, 2, 3, 2-methoxy, 2-methyl propane. Its name will be 2-methoxy. At the carbon, second carbon, we got methoxy, and then 2-methyl and propane. Are you getting my point?
Yes, sir.
And
Finish.
the product will be NaBr. Sorry, byproduct. This is byproduct. That never asked almost. Now see, if I'm going to give you a question like this, CH3C, CH3 and CH3 Br and CH3O negative and then Na plus. Please do let me know the product. Will you be able to
Sir,
solve it?
Br, Na will be replaced with Br.
Yeah, that is the byproduct that almost never asked. We deal with the main product. Follow the mechanism. This will be negative, this will be positive.
Yes, sir. Yeah.
So did you get this product? Tell me.
No.
So what you got? You know what? This product is wrong. Why I wrote this product? Because simply the mechanism that I am trying to explain, it is based upon that. So I thought that you will eventually get this product because what I am doing, sodium has positive charge, oxygen has negative charge. This alkyl group has positive charge, this has negative charge. So you are going to connect this and you will get as a
Yes, sir.
byproduct NABR. What we are left with, this positive and this negative. So you are going to connect this. Are you getting my point?
Yes, sir. Yes, sir. I
Again,
was
you are
trying to
going
do
to,
that.
if you are going to see, this is positive and this is negative. So this will be as a byproduct and what we are left with, CH3O and then this positive. So this negative is going to connect with this and you are going to get this, right?
Okay, sir.
But the problem is that I thought you will get this, but this product is wrong. So what is the main product? Whenever, always remember that first of all you are going to write it and write it wrongly like this and you are going to cut it. Okay, and then you are going to go see what I am going to explain.
Yes, sir. Phenols.
So see, always remember that this primary is quite good. Primary alkyl halide reacts and that wait a minute. Secondary and tertiary alkyl halide. Here, elimination competes over. Elimination competes over substitution. In primary, it's very easy to substitute, you can see primary alkyl halide is easily substituted. Primary alkyl halide. We are not going to talk about the primary tertiary alkoxide. So in secondary and tertiary alkyl halides, elimination will complete over substitution, and the product you will get, the main product, as you can see, dehydration will take place there. This is tertiary halide that you are taking, and this is Na positive. You know that this is negative O, and this will be CH3. So what will happen? It's very easy to understand that you will be seeing that CH3 C double bond CH2 alkene will be formed CH3 along with byproducts like NABR. I will explain how does this takes place, and along with CH3OH alcohol. So see what will why this product why this product formed. It's because this alkoxide group, alkoxide, is not only nucleophile, but it is also a strong base. It is also a strong base. Now see, if Br will be removed from here, it will go with sodium. Yes or no? If Br will
Yes, sir.
remove from, and see what happened here, CH3, you can take, it is CH, and this, if Br will go from here, carbon will have positive charge, deficiency of carbon. So what will this carbon do? It will take electron from hydrogen and it will basically make bond with carbon. That will be in result of formation of alkene, and this hydrogen will go with this oxygen. So it forms CH3OH, NABR, and here it will be an alkene form. So please do write it. Then I'm going to give you a question. Always remember that the alkyl halide part, if it is primary, then ether will easily form. But if you are getting an alkyl halide which is secondary and tertiary, then you are going to get an alkene instead of ether, because elimination completes over substitution, because this alkoxide is not only nucleophile but also a strong base. So please do write it and let me know.
Yes, sir. Finish.
Very good. Please wait a minute. Now I'm going to give you a question. Please prepare your mind, and the question is based upon this concept. And it's a question from NCR. This is very easy if you get the concept. Write with me the question. The following is not an appropriate reaction for the preparation of tertiary, T for tertiary, butyl ethyl ether, and reaction is given as C2H5ONA, and there is CH3 CH, and then again here it is CH3 and CH. And if you are going to react this, please read the question carefully before solving it. This is CS3, and this is also CS3. Now the question is, what would be the measure product? What would be the measure product of this reaction? Second question is, write a suitable reaction. For the preparation of tertiary butyl ether. Oh, wait a minute, it's wrong now. Tertiary butyl ethyl ether. This it's common name, and what it's no need to worry because its structure is given. So please do let me know if you have any doubt.
Sir, the answer is uh
Yes.
CH3, C, and then
Okay, I'm going to write it.
down
What would be the major product of this solution?
the major product
This
would
is
be
the,
CH3.
wait a minute, just let me write with you. Is it CH3 and then,
And then like C, and then down is CH3, and then double bond CH2 plus NaCl plus CH3,
okay, got it. This is the
CH2.
main product, right?
Yeah,
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 this is the
yes.
main product. Now we don't need to write the other products. Okay.
Okay.
So what is the suitable reaction for the preparation of tertiary butyl ethyl ether? Did you write it?
Sir, what does that mean?
Yeah, what you just said.
What does that mean?
It is
Write the
mean,
suitable
see,
reaction for.
isn't this reaction is wrong because alkyl halide is 3-degree alkyl halide, and whenever 3-degree alkyl halide reacting with alkoxide, then elimination completes over substitution. What was in the first question? What is the following is not an appropriate reaction for the preparation of tertiary butyl ether. So you need to write the appropriate method. So it's very simple. So what I'm going to do is just change it. What I need to change? Just make tertiary alkoxide like this. This is C and this is ONA and this is CH3 and this is CH3. And what I'm going to do, make it a primary alkyl halide. What I just did change the position. ONA was with CH3, so and Cl was here, so I just transfer it here. And now, since it is a primary, it can give a good product. This is negative, this is positive. Now this will be added in this, and you will get it. Are you getting my point?
Yes, yes, sir.
Or should I explain it again?
Sir, can
Please
you
let me
explain
know if you
again?
need another explanation. Yes, do you need another explanation?
Yes, yes, sir.
Yes. So see, the questions was asking about what is the suitable method to prepare this tertiary butyl ethyl ether. So what I just did is there was Cl here. Oh, sorry, there was Cl here at the place of ONA, and one there was Cl. It was 3-degree alkyl group. That means uh, elimination completes over substitution, and this product will form. So in order to make a sorry, to form or produce an ether, we need to have primary alkyl halide. So Cl was here, so I just transfer it here, and ONA was here, so I just transfer it here. And then follow the mechanism as it is. The mechanism I have taught you. What you need to do is very simple. There will be negative, there will be positive. There will be negative, there will be positive. So this will make NaCl and it will be eliminated. And this CH3, CH2 positive will go with this, and this you will get. Got it?
Yes, sir.
So please write and let me know when you are done.
Yes, sir. Finished.
Very good. Now see, this we are talking about basically general alcohol converting into ether. Now phenols are also converted to ethers by this method. By this method. So how it's gonna react? You can see this is our phenol. This is our phenol. that is reacting with NaOH, you can take, and then you will get phenoxide ion. You will get first phenoxide ion O minus Na plus, and then reacting this with phenoxide with alkyl halide, you will get ether like this. Alkoxybenzene. See what happened here. There is positive, there is negative. And in here, you know that oxygen will have negative and this will have positive. So this sodium will go to oxygen and this hydrogen will combine with OH to form water and it will be eliminated. And here are phenoxide forms, and this phenoxide react with alkyl halide to form ether. So please write, this will be like this and this will be a diagram of this.
Yes, sir. Finished.
Yes, very good. Now we are going to start the chemical properties of this ether. So chemical reaction. It's very easy chemical reaction, and here the first reaction is basically cleavage of CO bond. Cleavage of CO bond in ethers. To see what it is. If you have an ether ROR and there will be an alkyl hydrogen halide, there will be cleavage of CO bond. In what sense? This will be broken and there will be negative. Basically, this will be also broken, and you can see ROH, alcohol will form, and H. This is ROR and then reacting with HX. So ROH and then RX will. Now again this ROH will be reacting with HX, this HX. If you have HX in excess, again the bond will be broken. In the same way, negative, positive, you can take this negative, this positive. You can take this negative because they are more electronegative, this positive, and then mix them. This is positive and this is negative, then alkyl halide form. This is positive, this is negative, then water phase. Are you getting my point?
Yes, sir.
If you have CH3 OCH3 and you are going to react with this HI, please let me know the product. HI is in excess. I wrote it, HI is in excess. So you are going to react.
Sir, CH3OH plus CH3HI. No, CH3I. Uh,
See, what you just did, this is
Hydromethyl.
negative, this is positive, this is positive, this is negative, right? So what you need
Yes.
to do is, it's very simple, CH3OH and along with CH3I. Now again this alkyl halide CH3I is gonna react with HI, right? Because it is in excess.
Yes.
Are you getting my point? So
Yes,
this
sir.
will be what? Wait a minute. This is CH3I. Okay. This is HI and this is CH3. CH3 what? Basically, we need to take this alcohol, CH3OH. So again, what will be the product? CH3I along with what is the another product? H2, right? Nafisa,
Yes, sir. Yes. H2O.
should I explain it again? Because I was stuck there. So what you need to see here is ether hydrogen halide will form this. Then again this alkyl halide will react with this hydrogen halide. Okay, sorry, this alcohol will react with hydrogen halide. Again, you can see this is your ether reacting with hydrogen halides. Then alcohol and alkyl halide will form. So this alcohol is gonna react with this, and then we will get CH3I and then along with H2, right? This
Yes,
is the
sir.
product. Okay, thank you. So please write it and let me know when you are done with this.
Yes, sir. Finish.
Finished? Okay. Okay, now see, this phenol can also be cleaved or react in the same manner. That means same things will be, same process will be there for this. So can you write a reaction for this in the same way that we just did?
Sir, H will replace R plus RX.
So it will be like that. We got phenol,
Phenol.
right?
Yeah. Plus RX.
Along RX, alkyl. Right. Are you done with this?
No, sir. Still right.
Okay, please write.
Yes, sir. Finish.
Write with me. The order of reactivity of hydrogen halides is as follows: HI, HBr, and then S.
Yes, sir. Finish.
Now see another chemical reaction of this. I'm going to discuss. It's very easy or important. If you have this CH3, and if you are going to, don't be confused with HI, that is hydrogen iodide. To see what is the product, what will be the product here. It's very easy to understand. There can be two cleavation. That means basically, if you are going with my mechanism, this will be HI, right? So if I'm going to take it, there will be negative and there will be positive, right?
Yes, sir.
Now, if I'm going to tell you that I'm going to take this positive and this negative, so there might be a question in your mind that, so why are you not taking this as positive? There is possibility that I should take that carbon with a positive sign. Yes or no? Both are possible.
Yes, sir.
Now see, if this this I'm going to take positive, that means this is super primary. Do you know what is super primary?
No, sir.
Do you know what is primary?
Yes, sir.
So what is primary? You know that this is CH3 and this is CH2 plus. That means this is primary carbocation. And if
Yes, sir.
carbon is present, there is no carbon attached with this carbocation. That is super primary. That means this is very, very unstable. Yes or no?
Yes, sir.
Because At least in primary, someone is there to support that carbocation to give electron. If it is secondary carbocation, it is more stable. If it is tertiary, that is very, very good. Yes or no? So if you are going to take this as positive, that means super primary carbocation will form. And if you are going to form this carbocation, what will be the degree of this carbocation? 3 degree.
Yes, sir.
Which one you want to prepare? Super primary carbocation or 3 degree carbocation? Which one will you prefer? What will be the stability of this?
3 degree.
3D. That's good. And can you change this? Can you take iodine as positive and hydrogen as negative? Can you change this? Yes or no? Why I wrote negative sign on iodine? Why I wrote negative sign on iodine? Can you answer me? Nafisa, am I audible?
Yes. Yes, sir.
So, can you answer it or not? Just let me know. It's not.
No, sir.
So you don't know why I write negative positive. This is we are at the end of second chapter. Why I write here HX? Do you know why I write negative here and positive here? Yes or no? Just answer me.
No.
You should ask, no? Sir, why are you going to write negative on X and hydrogen always on positive? This is on the basis of electronegativity. Do you know what is electronegativity? Do you know what is electronegativity? Please do answer me, yes or no. Yes,
Yes.
or no? Yes, what it is? See, property of any element, or you can take group, to withdraw, or you can say attract bonded electrons, or you can say shared pair of electrons. Shared pair of electrons. So this fluorine is the most electronegative element. I'm going to write fluorine is the most electronegative element, oxygen is the second most electronegative element, and nitrogen is the third most electronegative. And you know what? This 17 group, fluorine, chlorine, bromine, iodine, they are very electronegative, but not more than oxygen and nitrogen. And as you know that hydrogen is on the left side of periodic table and iodine on the right hand side of the periodic table. When we move from left to right, electronegativity increases. That's why iodine is more electronegative than hydrogen. That's why this hydrogen's electron will be slightly displaced towards iodine electron. This hydrogen electron will be slightly displaced towards iodine electrons, because it has a tendency to withdraw or attract shared pair of electron if there is uh, lesser electronegative than this element is there. So it will have delta negative and there will be delta positive. This plus or minus writing of mine is only to understand what happens here. Since if one electron will be gained, there will be minus one. If one electron will be lost, there will be plus one. But since it is slightly displaces the electron towards itself, so delta negative, delta positive. Are you getting my point?
Yes, sir.
Now see this oxygen, second most electronegative element. Oxygen will be always in negative except fluorine, if it is gonna react, if it is gonna have a compound or molecule with fluorine, then it will have positive sign. Except this, with every compound anywhere, oxygen will have negative oxidation state or negative charge. Are you getting my point?
Yes.
So now you can see this carbon is less electronegative than oxygen. That's why there is negative, there is positive. This carbon is lesser electronegative than oxygen. That's why positive and oxygen are negative. So what I wanted to tell you is that this is this clear, this negativity and positivity? Is this clear?
Yes, sir.
Okay. Come to the point. Just write this point, these things. Then I will erase it and move to the next.
Yes, sir.
Very good. So what I'm going to explain is this point. Wait a minute. Uh, I'm going to write it. It's better to write again. So you can see that we had this, right? So again, I made this mistake. CS3 this, and this is CS3, and this is CS3. And if you are going to react this with iodine, so there can be two possibilities in a fissure. So there will be positive and there can be positive and there can be positive. Negative will be here and negative will be here. Can you answer me now? Can hydrogen will have negative sign? Yes or no?
No.
Because it is less electronegative than iodine, that's why it will have positive sign. Because the element which
Yes,
is
sir.
connected with its hydrogen is very, very high electronegative, powerful. So it cannot be iodine. Okay. So we have two conditions. The first is this gonna connect with this, and the product will be like this CH3I, and this gonna connect with this, and the product will be like this CH3, 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 and then OH, right? But this is not gonna happen.
Yes,
You
sir.
know why? This is not gonna happen because this is super primary. This will form super primary, which is very, very unstable. And basically, if the product will form, will be very in minor. The composition will be very minor. And if you are going to make it, see what is the difference, what I want to tell. If you are going to take tertiary carbocation, the product is the main product, and you can say the major product, main product or major product. Iodine will come here, and this is CH3. Got it? I will also explain the mechanism. There is nothing to explain the mechanism. If I will write it, you will get it.
Okay, sir.
Then
No, sir. Wait.
take your time, no problem. So you are going to do literature in bachelor, right? After class 12.
Yes.
Nice. No interest in science.
No, sir. Actually, I wanted to go for computer, like programming. But then I guess you have to take CS. But I'm currently taking informatics instead of computer science. So yeah.
Okay.
Yes, sir. Finish.
Okay. Now see, I'm going to write the mechanism and let me know if you got it or not. The hydrogen iodide, since iodine will take electron from it, so it will be H positive and it will come to oxygen and make a bond with this. Okay. And this step is basically slow. And as you know that this oxygen wants to stabilize itself. So there will be formation of carbon. Again,
Yes, sir. Finish.
very good. I'm going to give you a question. These are all reactants that are going to react with HI with heating. There will be heat also in this reaction. Please let me know the product.
Sir, the first one, I will replace the O and then plus CH2,
Wait a minute. Wait a minute.
CH3OH. Okay.
Is this what you do? Is this what you got?
Yes.
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 So see, this will be positive, this will be positive, and this will be negative. So you have to decide which carbocation is basically more stable. The carbocation which will be more stable will go with iodine. Wait a minute, wait a
Sir,
minute.
the more stable one would be the CH.
Oh, wait a minute. Hydrogen iodide, right?
Yes.
So this will have positive charge, this will have positive charge. This is what you get. Okay, what about the next one? Are you done with the second one?
No.
So it's
No, sir.
very easy. You can say that this will have positive charge, this will have positive charge. And since we are going to react this with HI, that is constant, this will have negative and this will have positive and this will have negative. Tell me which carbocation is more stable, tertiary or primary?
T-shirt.
Tertiary. So with this positive, the major product will be this. If you are going to make this, it will be minor product. So the product will be CH3, CH2, CI, and then CH3. Got it?
Yes, sir.
Please let me know the name of what is the product or name of the next product. This. Can you do this? See, this will have negative charge, this will have positive, and this will have positive, right or not? Because this is also carbon, this is also carbon. Now you need to tell me, this is more stable or this is more stable? Can you tell me? See, positive charge on double bond, highly unstable, highly unstable. So this iodine, since we are going to react this with this iodine, it will have negative, it will have positive. So this will move to this because it's stable due to resonance also. So you can see the major product will be this. Is that clear?
Yes, sir. Okay.
Is to write it.
Sir, the first one I said was correct.
Yes, yes. It is similar to mine, right?
Sir, what did you say?
This was the first one, no?
Yes, sir.
Yes, it's correct.
Yes, sir. Finish.
Now moving to the next chemical properties, that is electrophilic substitution. To see what is electrophilic substitution, we are going to learn about it. So can you write the resonating structure of this in the same way that we did for phenol? Can you do this?
Yes, sir.
Okay, please do it. After this, which chapter we are going to do? Chemical kinetics?
Sir, you were lagging.
I'm asking after this, we do chemical kinetics, right?
Yes, sir.
So see, I'm going to write the resonating structure of this. This bond cleaved and moved to this, so it will have negative. There was double bond, there was double bond, and now double bond moves here. And since oxygen donated one of its electrons, so it will have positive charge. Now again, this moves to this and this. So it will have Again, the negative charge is here, double bond moves to here, and there was double bond and there was double bond, OR positive. Now again, if you are going to move it, the second bond you have to move, because if you are not going to move it, this carbon will be making 5 bonds, which is not possible. So negative charge will be here, double bond here, here it was, and then OR positive. Now again, if you are going to move it here, already this carbon is making 4 bonds. And if you are again going to move this, so it will be 5 bond. That's why I just moved this bond to here. So you can see delocalization of 5 bond took place. That is a resonance. And in this, we are going to learn what you just said.
Yes, sir, I did the resonance.
Very good. Halogenation. So you can see we are gonna do halogenation in methoxybenzene. Methoxybenzene. And this is our methoxybenzene. And its common name is anisole. So if you are going to do bromination, that means you are going to react this with Br2 in ethanoic acid. And you will get bromine at para as well as forth. You will get bromine as at para with respect to this OCH3. And you know which one is more stable? The para. So you are going to write the major and minor product as well. This will be major, this will be minor. And its name will be O-bromoanisole in terms of common name, O-bromoanisole. And this is P-bromoanisole. This is a small. Please do write.
Yes, sir, finish.
Now see, we are gonna do Friedel-Crafts reaction as we have seen in the previous chapter, Friedel-Crafts alkylation and acylation. So both will be here. This is Friedel-Crafts reaction. Here you can see we are gonna react this anisole to form alkylation first. So in order to add alkyl group, we have to react with CH3Cl in the presence of anhydride AlCl and CH2 carbon disulfide. Then there will be addition of CH3 at ortho and at para. Now this is basically minor and this is major. And its name will be 2-methoxytoluene. And its name will be 4-methoxy. This is basically Friedel-Crafts alkylase. So how we are going to prepare acylation? Acyl halide will be added. So again the same. This is your anisole. In order to add acyl group, we have to react with it. acyl CH3COCl in the presence of anhydride AlCl3, anhydride AlCl. So you can see there will be addition of acyl group. That means basically COCH3 at ortho and COCH3 at para. And you know which one is major and which one is minor, right?
Yes, sir.
This is your minor and this is your major. Its name is basically 2-methoxy acetophenol. And this is basically 4-methoxy acetophenol.
Yes, sir. Finish.
Very good. Now the next and the last reaction comes, that is nitration. That means basically we are going to add nitro group in this anisole. So we have an. So in order to add nitro group, we have to react it with H2SO4 in the presence of HNO. Then we will get NO2 at ortho as well as NO2 at para. And you know which one is minor and which one is major. Its name is basically 2-nitroanisole. And its name is 4-nitroanisole. Please do write it.
Yes, sir. Finish.
So this is it for today. Thank you so much. In the next class, we are going to start chemical dynamics. Okay.
Yes, sir.